is UCL School of Management, where I teach predictive systems. So what I'm talking about, I've been thinking quite a lot. You know, this is the sort of 5% time. This is what keeps me awake at 1 a.m. in the morning, is what I'm going to talk about. But I think we talked, you know, the two previous speakers have just touched on themes, right? Which is, you know, how do we deploy models and how do we integrate models into things? And I guess I've got to the point where I've started trying to think about whole businesses as models. And I teach predictive systems on a master's program in analytics, and sort of teach innovation strategy on the MBA program and various things. Although background is in computer vision, so I was saying the last time I hung out with Mark Nixon might have been on the beach in Rio in 2007 or something. But this, I quite like this quote, which is that our businesses are, you know, you can swap out internet for AI or blockchain or computer vision or whatever you're working on at the moment. But most of the sort of management processes are 20th century and mid-20th century. Even the product design, right, the stuff that is new and lean startup is largely based around ideas from the mid part of last century. And then the management structures are, you know, in terms of hierarchies, who says what, and etc. And the fiduciary control mechanisms are 19th century at best, but go back a long way, right? I mean, we're going back to what's the structure of a company, what's it there for? So I try to come up with a sexier title than towards the use of graphical models. So what I'm really trying to think about is what is a business model, and if you go to a business school or an MBA program, the things that they call models are very different from the things that people with a kind of computer science background or just a science background would call a model, right? So you've got great, you know, philosophers, Nancy Cartwright or Ian Hacking. You know, what does it mean to build a model? How do we partition or abstract parts of the world so that we think of them as models, and what's the utility of a model? And machine learning, in my sort of characterization, is a little bit about industrializing scientific processes in some sense. We can argue whether AI's goal is cognition, you know, in a strong sense, or whether actually we're trying to understand how to generate or auto-generate models. But there are a few things that I'm starting to take seriously. One is that a lot of management ideas are anecdotal at best, right? Most of the literature is based on a few interesting observations and a few narrative stories, and then a lifetime of selling books off the back of it. Software 2.0, you can argue with the detail of that blog post, but I think it gets at some interesting truths. There's a whole load of ways you can criticise it, but this idea that we are changing the way we build systems, and those systems are going to be built around the ability to learn, so constant evolution. And the third point is we're not going to see the slowdown of these types of technologies, right? You know, we might hit a blip pre-quantum computing in terms of capacity, but in general, over the next 100 years, we're going to create more and more systems that have more and more capabilities. And exactly how they're integrated into the economy is anyone's guess, but the chances are that we're going to have more and more systems with tightly integrated humans in the loop in some way, shape or form. So the idea about 2.0 is that rather than just producing a single program or a single system, we set up an environment in which the system can iterate in some way to our intended goal, optimization. My first company I set up was a company called SITUATIONAL about 10 years ago now, sort of trying to industrialize certain types of optimization process. And this is interesting. So, you know, I finished my PhD in computer vision in 2010, I think, possibly, and so slightly missed the 2012 wave of deep learning, right? But something as trivial as dropout in terms of organising a structure and organising a network has had huge effects, right? And I'm talking in TensorFlow, so I thought I would quote a TensorFlow advocate by saying, you know, we haven't really understood at all how to optimise certain types of structure. Have we understood how to optimise companies? Probably not, right? And if we can discover in the early part of the 21st century that deleting 50% of your neurons gives you a much better network, then what does that really mean for humans, right? Do we optimise how these things work? And because I'm at a law firm now, I pay a little bit more attention to sort of NLP, and this was just progress, right? This stuff is actually happening at a frightening rate. Every time we come up with a framing of a problem, which is like, well, this should be challenging, it turns out, in the way the problems are framed, as long as, in some sense, we're not making a lot of progress, right, towards a real understanding of cognition. But we are making incredible progress at knocking off framing problems that we thought were important and are useful, that are capable of being tackled by these technologies. So, business models. The first half of this talk, which is 3.5 minutes or something, is 3 days on an MBA program, so we're going to have to rattle through it, and some of this stuff might be relevant, some of it might not, but there's so much material that you can read up on. So my goal was to try and stimulate thought, and the guy that has stimulated my thinking process most recently by all the moments is a guy called Simon Wardley, and trying to understand mapping technologies and technologies' use within business. And there is an online book for Medium, and you can read about it. It's like 20 chapters, and I think I've read those 20 chapters about 5 times now. I keep learning new stuff. And the general idea is building directed graphs of businesses to understand business strategy. And so and then thinking about situational awareness and business patterns. So this is a sort of a now fairly famous business pattern called ILC, where a company builds an ecosystem model, say Amazon, builds a set of commodity services that can then leverage an ecosystem of apps or elsewhere service providers, higher value service providers, that then they can monitor the use of and use data mining to figure out how to build a higher value commodity service that they expand upon. Right? And we're now a decade or 15 years into this model being used. And it's interesting in its own right, because Simon's work pulls out something like 60 standard business patterns, right, that some people understand and some people don't. But the main part is that it reduces that into what I would think of as a model. It ends up with a directed graph in a metric space where you can start to measure stuff, and that becomes interesting. So this is where I started some of this journey. This is how I think about optimization problems, and the Wardley Map of this graph starts with the customer at the top and a set of things that the customer requires, and it ends up with a dependency graph of things that the customer values, right? Down the bottom ends up with things like the commodity already, like power, and at the top you end up with your sort of user-centric version of the world that we've, in terms of design methodology, we've worked on for 50 years or so. And we join it up, so the CRM is built on top of some compute power and is accessed by a portal, and you get the idea. And if you don't, go and read it. And then the idea is that actually these businesses these directed graph models of businesses sit in a metric space, and we can start to measure how developed or not they are. So everything starts on the left-hand side of the graph as being this kind of R&D, and everything at some point in time ends up on the right-hand side as being commoditized, right? And things like electricity or nuts and bolts are commoditized in the end, and things like machine learning for the last 20 years have been on the R&D side, and then fantastic companies like Seldon are in a process of productizing various aspects of delivery. This model is quite complicated and can represent lots of different aspects of a business, right? Everything from the strategy, how does movement important, how do we outplay a competitor, through to things like the structure of teams, so HR functions, what's the style of team across this representation of a business. But most of the time when we talk about businesses as a business model, we're talking about canvases, structured lists of things. So if business model canvas is a useful tool. If you go on YouTube or something, find the 3-minute video if you haven't come across it before, but what are the foundational building blocks? And what it really ends up with is a structured list, which is if you're thinking about a business model, be certain that you put something in one of these boxes so that you haven't forgotten at all about it. And so one of the things started to try and do is take something that I think is realistic and useful but complicated, and try and understand how we might create management tools out of it, right? Because no one not enough people are going to sit and educate themselves on graph theory and the structure of graphs, etc. So the first thing, working with a guy actually at the back of the room, Dave Chapman, is to flip it round so that the customers are on the top and the delivery mechanisms are on the bottom. And then the value proposition itself starts to become like a clique or a subset of those key graphs. Like, what do I actually require to create a minimum viable product, etc. And then you can start to build it out and it gets more interesting, okay, right? Not just the value proposition, but what are the supporting activities for this prototype of a business? What are the resources, where do they sit? And we can start to get at more complicated things that start to encroach on a sort of graphical model representation, like flows. That might be flows of capital, i.e. we've split off something that looks like a P&L, or they might be flows of data, or increasingly they might be flows of models of data, right? And the reason I'm interested in this is actually getting to the point where models themselves flow around businesses potentially. This is you breaking off the P&L, right? So you've got your revenue structures and you've got your cost structures, and so I can start to see how we might get from a graph representation of a business to a P&L representation of a business, and how do we have a management tool to span the two. And then also we start to get to sort of interesting things that, again, I'm sort of bastardizing plate notation from graphical models in terms of what are you measuring and what parameters are you doing. And some of those in a business are well known, and some of those are unknown, and some of them are not measured or missing. And when you talk about sort of lean startup type trajectories, you're thinking about, can I measure everything or anything, and what's the one metric I'm trying to build? And in reality, across any single business, we're trying to come up with a framework that allows us to trade off the difference between metrics and then how we parameterize that business at any stage. And that's a generic business, right? So starting this business model canvas was like how few, if you're doing a startup, how few pieces of the jigsaw puzzle do you need to concentrate on? But in reality, we would like to have a model that builds out a more and more complicated thing. And so one thing that I've been teaching on the course over the last few years is the sort of machine learning canvas, right? Which is, again, how do you strip it back? If you're designing a system that goes into a business context, how do you deal with it? This is online. This is by a colleague of mine called Louis Gerard. And you kind of got things about the prediction life cycle, like what businesses or decisions are the business trying to make, and then how do you translate that into a particular type of task. And then on this side, you've kind of got an inference type cycle, which is about the data itself, features and learning. And one of the things we've been working on, when I say working, it's like, conversations after work or at the weekend to try to figure out whether these things all fit together. But one thing that I've been working on is trying to expand the canvas model in a meaningful way. So can we think about the parts of a machine learning driven business or aspects of a machine learning driven business sit inside a common framework? So what's a data value proposition? What's required on the customer side or the business unit consumer side to get going? What's required on delivery? How do these things fit together? If you're thinking about Seldon side of the world, how do we get from an initial model building scenario into production? And how do we communicate these things? How do we model these things? How do we build strategies around these things? And again, trying to keep it consistent so that we can get back to something that we would genuinely think of as a model, not as a training aid for people that don't know what a model is. Say that, don't quote me. So this is another common representation of that. If I take the business model canvas, ignore the fact that we've expanded it, we start to think of things about what are the market aspects of that. This is a startup entrepreneurial journey, right? What's the market? What's the capability to deliver something into that market? And then, is it viable? So, what's the cost associated? What's the return? Is this an opportunity? And starting to map that back then into a machine learning business, and a machine, for the sake of argument, a business where also we can start to prioritize. So what third-party services do we use? Like, do I build my model from scratch? Do I consume a model under an API? What are the important bits to my customer in terms of my ability to solve a problem? Which parts are part of the solution, and I need to deliver in-house and keep control of, and there is value in the IP of the relationship, versus what can I move out onto third-party services. But it also, do a little bit, how much time have I got? 6 minutes. Fine. It's flying through. There is a little bit here also about the structure of the teams, right? We're talking about how to deploy models, how to build, what to build in-house, what to pass on to other people. And so another thing that, as technologies move from the genesis or creation or invention through to standard things that we can consume and we have markets for and we sell, there's also this notion in which the sort of learning loops get more complicated. This is one of Simon's slides. So, there's a sort of, if you don't have any of the infrastructure around a market or a business, just get on with it. Versus actually, when we're down here, we want to think a bit more carefully, right? We also change methods, right? We go from lean, to waterfall, for example, as we move across the sets of technology stacks in market. And so started thinking a little bit more about what those potential flows look like, right? So on the middle graph, we had a flow of capital, for example, against P&L representation of the business. And here, and sort of Alex alluded to a little bit, which was what are the flows of information? So I don't have the 9 to 12 boxes that you put up, right? So again, the idea that a canvas being a list of things is a certain level of abstraction, but one of the sort of famous information cycles is kind of CRISP cycle, which is we go on a product team or a problem team and we go iterate between business understanding, data understanding, and to a certain thinking about what the business design system would be. And then once we've gone through enough of these iterations to think that we understand what we're doing, we go down into a solutions team type model and we iterate between the task and the model, how we evaluate it in terms of training, testing, metrics. And we might have to go through several iterations of this within a business, right? Which is, can we figure out the viability of our approach to a problem? And then we go through the first online thing, which is like, okay, how do we deploy it and get it out into the world? And what are the measures that we need to worry about, or the list of things we need to worry about in production as opposed to any sort of design and build? And then what do we think of performance, right? And again, the performance versus production type things tend to flip around on your cost structure. So, what's a good, think about taking a confusion matrix and turning it into a cost matrix in terms of ROI against a true or false positive type scenario. And then there was an interesting paper from DeepMind about last month, I think, on the structure of things to worry about when a model is in production. So, what do I need to, do I need to redesign the product itself? So you've got a product team sitting here in kind of design capacity. What do I need to monitor in terms of drift of the model or the changing data? Or you get into sort of social sciences like the hermeneutics, right? How does my ability to influence or intervene in the system alter the behavior of the system itself? Do you get emergent properties? How, with a live system, what are my sort of prevention and risk measures, etc., etc. And the idea would be that we can manage to not just map the usual measures of flow on a business in terms of capital, but we can start to measure flows of people and information and potentially flows of models, right? How do we keep track of multiple models that are going in and out of production? And at the moment we are at the beginning of this century. It's not much of a challenge in some sense. It's an engineering challenge, but we're not changing models every X, and where the frequency is very short. Although outside of certain types of trading mechanisms, but most of the projects that we do in UCL School of Management are on timescales where actually these aren't continuously evolving, right? They're incrementally evolving systems. But I think over the 100 years we're going to get to the point where these are sort of live systems, and the management of companies have to have a very different sort of information available to them to make strategic decisions. Once we've got an understanding of business models abstracted at different layers, and we understand flows in businesses and we can communicate that, potentially we can get to actually building proper models, right? Because we have a representation, we have a metric space in which things that are business units or components move around, and as a first approximation, we might as well quantize that space, and then we can start to build normal models. Things that are absolutely known within a business, which is what most business models work on at the moment, versus abstracting to things that we don't know, or including weak signals, or learning energy models, or energy surfaces over weak signals. And I think that's the sort of trajectory we're headed on. 1 minute. This is the only thing I will say about law. I'm currently hiring, actually, so if you're interested in sequence problems, time series and NLP, we have a whole load of genuinely interesting things about how to understand the structure of law, and longer term, this sort of interaction between at least 2 technologies, but potentially 4 in terms of the structure of law. Computational law is something that's interesting. So the measurement process and the automation of the measurement process is a machine learning problem. And then the persistence and the update of that information as a result of the measurement process is a sort of database stroke DLT stroke blockchain problem. And how those systems interface with how we do the rule of law, i.e. how do we arbitrate between parties and how do we enforce between parties under the law, is I think a very open problem from a technology perspective, and I think we're just at the beginning of trying to do that. Last thing, acknowledgements. Colleagues at the School of Management for discussions around the structure of campuses. I've got the same as the sort of version that I presented for machine learning. We've got for blockchain as well, splitting technologies into sort of problem, solution, production type scenarios. And then the person who has genuinely changed the way I think about some of the things is Simon, who was good enough to give me some of his time when I say, but on page X you say this and I don't understand that. He's like, well, what I mean is, I'm like, fine, I'll catch up eventually. There you go, thank you very much.
Wow, that's I feel like the wind tunnel, that's epic. In fact, actually, I'm going to use the opportunity to ask a question first. I totally get the idea of mapping your business to improve yourself from the core. How much does this help you anticipate where a market is moving to? So using it to not only understand how your business should be structured, but where your market is moving to.
Absolutely. So, I mean, that's literally the whole point of it. Is to be able to say, okay, well, here are the chess pieces on the board, so to speak, okay, and we believe, actually, if you take it back to a sort of discrete model at the end, I can imagine the sort of DQN type model playing out where you're playing, 2 companies are playing AlphaGo against each other, right? Which is okay, if you're moving your piece here, I'll try and move your piece there. But the framework for Wardley Map is literally designed for trying to evaluate those things. So there's a lot of judgment involved, but if I pick one where a scenario plays out, right, it's okay, so take open source as a great example. Everything evolves, in this model, everything evolves, it's essentially it's normalized time. It's cleverly normalized time. This might as well be put, T on the end of this graph. And things move left to right, but you can obviously speed up or slow down the transition of technologies from left to right, and actually open sourcing is a great accelerator there. So you're seeing what people have learned over the last 10, 15 years is the ability to use open source as a strategic aim for building and defending marketplaces and platforms and platform economics, right? So actually open sourcing gives you certain different advantages, particularly when it comes to a business pattern play like ILC. So if you can take a common subset of technologies that people can build on top of that creates additional value from that first service, and you can artificially commoditize it by open sourcing it and distributing it for free based on your ability to reclaim value elsewhere in your business model, you are then able to capture a higher value commodity service under the same model and you iterate again. So, Google, Amazon, Netflix, this is well understood. Like I said, we're 10 years into this now.
Very good, very good. I know I'll be reading on the train home. Questions?
So you mentioned that it's going to move from Oh, sorry. So you mentioned the notes move from left to right as time goes on. Do they move up and down as well? How was the value chain visibility calculated?
Yeah, so that's a fantastic question. This is someone, at least at the back of the room, where we have long lunchtime debates about this at the moment. Short answer is that yes, it can also move up and down, right? So principally, can you develop a higher value service closer to the customer, closer to the purchasing point? Yes. Can a set of technologies sort of decrease in value to the point where they're not? Think about containerization potentially. Right? You've got a battle at the moment at the beginning of a war between containerization and serverless type infrastructures. It's possible under that model for them to effectively become less and less visible to the consumer, the end user of a product or a service.
Does that decrease their value?
Yes. So this is perceived value. So there is a complication about how you measure perceived value and how do you produce an actual metric on that space. And there are a few things that people are trying, but none of them seem the final story. And in the same way, there are at least two models that I've seen out of the UK for producing a metrification of this space. There's one out of Cambridge and there's one out of London. So exactly, if you think about how to project it, this multi-dimensional thing onto a 2D space, open question. And most of the things that have been done at the moment don't look like actual models for metrification of the space, i.e. they can produce superfine features for technology evolution. but certainly all of those methods will be applicable, right?
Yes, at the back.
Yeah, the question we very one side.
Nestor's in the room. Getting a slightly concerned now.
Yeah. A question on the data. I'm guessing ideally you need lots of data on the internal workings of companies, but traditionally that's fairly hard to get hold of, or is that not the case?
Not explicitly. So in terms of understanding left to right, lots of that public. So certainly at this end of the question is public data because it's normally research institutions, and a lot of the time, actually, data in the product and quality space is also public because it talks about feature sets and the ability to use it and the functional aspects of anything. And so the idea would be you can build topic type models off this stuff. Where you probably got less visibility is in custom build because there isn't any public type of documentation that might come out. But I think this is an open subject. If you look at the stuff that Nesta are doing on trying to map, take that last deep learning mapping paper, right, and scraping the archive, I think no one has really started out on the science of this yet. We're at the early stages, but do I think there are publicly available sources of data that are capable of modelling these spaces? Yes. Is that an answer?
Thank you for the question. So you mentioned at the very beginning of the question section how you may compete like one company against another company, and then you measure that. But then if you also bring not only those scientific measures into business models, but also bring the problems of the science, like A beats B and B beats C, but C beats A, how do you deal with that? And do you not think these kind of problems will make company models or business models get stopped where all are trying to improve on the same?
Absolutely. This is a Red Queen type scenario, right? Everyone will evolve. If we manage to create better business models, people will get better at exploiting the business models that have more value. Absolutely. On the other hand, at the moment we're flying pretty blind into the next 100 years, where we are going to tackle increasingly difficult problems of network complexity, right? And so actually understanding better and getting visibility of the structure of businesses, I think, is sort of a priority for people. But yeah, ultimately, if it gives you strategic advantage, your ability to think, most of this stuff has been developed in sort of a military setting, right? Which is, if you have a map, it gives you a huge advantage over the person that doesn't have a map. And it will be, and it is an adversarial scenario, and you're having changing landscapes, so these models change continuously, potentially. But I think you've already got that, even now in certain types of machine learning deployment, right? And so you get into those learning loops and technology-specific learning loops that, again, aren't, I don't think from a management or a business perspective, that are that well understood at the moment.
Now going towards collaboration, you're seeing that a lot of, even though blockchain, you're seeing lots of unlikely allies or former adversaries coming together. So would the same model work in that situation?
Yeah, I mean, this one actually, this is an example of a business model that's not adversarial, right? The two counterparties here in this seek common advantage, right? You're getting into ecologies of businesses, and if anything, over the last 15 years, we've learned quite a lot about distribution models or platform models. And so there, it's not straightforward adversarial company versus company. The question is across these complicated supply chains and delivery chains, actually, where are you as a company sitting, and what value do you deliver and extract? So this is not adversarial only. We are increasingly understanding more and more complicated, complementary sort of ecosystem ecology business models. On the other hand, particularly at this end of the spectrum, there are straightforward, monopoly type scenarios, which is how many companies do you want in the space, and what's their advantage, and what value can they extract, and you end up with counterplay, right? Proper strategy. Does that answer the question? Yeah. Am I finished now? Am I done? No, I'm still going. Yeah, cool. I'm getting thirsty.
I guess one question is, I guess what you've shown us is how you use graphical models to explain different structures you find organizations between organizations. But I guess, have you, using these methods, actually found something non-obvious in terms of, have you discovered something in maybe better structures, etc. In, let's say, like, leadership hierarchy or something like that?
So personally, no. Are there some practitioners of this as an early methodology? Yes. So actually, take Simon. Simon took a job at Canonical and grew their online server business from 3% to 70% in 3 years. So basically dominated the current server market by using some of these techniques. And if you look at GDS and the British government, Liam Maxwell, who's just gone to head of public services at Amazon, they believe that the UK has saved about £50 billion on project management fees in the last 5 years by implementing some of this stuff. So there are people in the market that are great components that have fantastic things.
Who's the second person you mentioned?
Liam Maxwell, who was with the government and has now gone to Amazon. I can't imagine why. Okay.
Excellent, very good.
Thank you.